A celestial spectacle is unfolding at this very moment, captivating astronomers worldwide. Betelgeuse, the mesmerizing red supergiant located on Orion's shoulder, is undergoing a remarkable transformation. This giant star, renowned for its bright red hue, has been a fixture of the winter sky for centuries, enchanting stargazers from ancient civilizations to modern-day scientists. The significance of this change lies not only in the transformations occurring within the star but also in the magnitude and rapidity with which these changes are happening. This immense star, hundreds of times larger than our Sun, showcases the dynamic and unpredictable nature of the cosmos. Betelgeuse's luminosity, the intense brilliance that defines its presence in the sky, has surged by an astounding 50%. Imagine a light bulb suddenly shining twice as bright, illuminating its surroundings more intensely. This is the phenomenon occurring with Betelgeuse on a cosmic scale. At the beginning of this year, Betelgeuse held the esteemed position of the 10th brightest star in the night sky. Its steady, familiar light was a constant presence, symbolizing stability. However, this unexpected increase in brightness has elevated it to a notable new status, now shining brightly as the 7th brightest star in our awe-inspiring night sky. This sudden enhancement has generated excitement and curiosity within the astronomical community, prompting new observations and investigations to understand the forces driving this dramatic change. Betelgeuse, a colossal star in the final stages of its life, is of enormous proportions. Its size is so vast that if it were placed at the center of our solar system, it would extend as far as Jupiter's orbit. Eventually, this star will undergo a collapse, resulting in a powerful supernova explosion, potentially leaving behind a neutron star or a black hole. The anticipation surrounding Betelgeuse's supernova is due to its expected spectacular display. Located approximately 650 light-years away, we are in an optimal position to witness this cosmic event firsthand. When the stellar explosion occurs, it will produce a breathtaking burst of light. Initially, a wave of neutrinos will sweep across the Earth, detectable by observatories worldwide. Subsequently, as high-energy photons escape from the expanding cloud of stellar debris, Betelgeuse will rapidly increase in brightness over the course of a week, reaching up to 100,000 times its usual luminosity. Depending on the strength of the explosion, this celestial beacon could rival the brightness of a full moon and might even be visible during daylight, casting distinct shadows at night. This magnificent event will last for an extended period, offering astronomers an unparalleled chance for detailed observations and potentially groundbreaking discoveries. While the supernova of Betelgeuse may evoke speculation and concern due to historical associations of such events with ominous portents, we can find comfort in knowing that we are safely positioned at a significant distance, shielded from any harmful effects. To fully grasp the mystery surrounding Betelgeuse, it is important to revisit the end of 2019. During this time, the red supergiant star began to exhibit notable dimming, a change observable even to the naked eye. Observations using the Very Large Telescope in the optical spectrum showed that Betelgeuse appeared roughly symmetrical, but its photospheric layers displayed signs of considerable disturbance. The photosphere represents the star's outer layer where light is emitted. Researchers also detected an expansion of the photosphere, giving the impression that the star was swelling when observed from Earth. This expansion continued at a steady rate of approximately 8 kilometers per second for most of the year until mid-November 2019, when the outward velocity began to decrease. By mid-November 2019, the flow of material from Betelgeuse ceased, leading astronomers to capture new optical images of the star. Their observations revealed two surprising anomalies. Firstly, a darkened region appeared in the star's southern hemisphere, creating a striking contrast with an earlier image taken at the beginning of the year. Secondly, the star's surface temperature experienced a drop, falling by approximately 80 Kelvin between January 27 and February 13, 2020. The brightness of Betelgeuse reached an unprecedented low about a year after the cessation of the outflow. However, the star gradually regained its brightness over the subsequent months, eventually returning to its usual magnitude. This led to the question, what had truly occurred with Betelgeuse? All available evidence strongly suggested that Betelgeuse had undergone an immense and unprecedented event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better understand, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior surges upward and outward, creating shock waves within its atmosphere. Over time, this material forms molecules and dust, partially obscuring our view of the star and causing it to appear dimmer. In the case of Betelgeuse, the SME resulted in the expulsion of a mass 400 billion times greater than what is typically observed during similar events on other stars or CMEs. This amounted to multiple times the mass of the Moon, propelled at astonishing speeds. Researchers noted that such an enormous mass ejection from a star's surface had never been witnessed before. The event allowed for direct observation and examination of surface details using the Hubble telescope, providing a real-time glimpse into the aging and evolution of a dying star. The SME had a profound impact on Betelgeuse, causing it to lose a significant amount of mass in a single event. This occurrence demonstrated that a dying star can experience substantial mass loss beyond its regular annual decrease due to stellar wind. In a way, it was as if Betelgeuse had forcefully expelled its upper layers and was in the process of slowly recovering from the aftermath of this event. However, following this dimming event, the star's behavior has undergone a change. Previously, it would pulsate or alter its brightness every 400 days, but now it is pulsating every 200 days. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple cycles of fluctuating brightness due to variation in its size and temperature. This red supergiant is known to exhibit two main periods of light pulsation. The first period lasts 400 days and is believed to be caused by pulsations in the fundamental mode, while the second period is a longer cycle of approximately 5.6 years, and its origin remains unknown. In their research paper, scientists utilized computer simulations to gain a deeper understanding of the events that transpired. They proposed that an unusually hot gas current, resembling a large and intense bubble, emerged from within the star. These occurrences of hot gas bubbles occasionally arise due to the star's turbulent and convective envelope, which can be likened to a pot of boiling soup where the material is constantly in motion and mixing. As this hot bubble ascended and broke through the star's surface, it triggered the expulsion of stellar material. Interestingly, it also disrupted the star's regular pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the star to transition from its usual 400-day pulsation to a new 200-day pulsation. Astronomers anticipate that the star's regular motions will gradually stabilize, with the unusual pulsation over the next 5 to 10 years ultimately restoring Betelgeuse to its normal 400-day pulsation. Regarding the possibility of a Betelgeuse supernova, astronomers speculate that it could occur at any time within the next 10,000 to 100,000 years based on factors such as the star's color, brightness, size, and estimated age. Scientists suggest that Betelgeuse is currently in the early stages of helium-to-carbon fusion. This process must continue through oxygen, silicon, and finally iron before the star's core collapses under its own gravitational pull, leading to a cataclysmic explosion. Since Betelgeuse is located 650 light-years away, any supernova event happening at present would only become visible to us after 650 years due to the limitations imposed by the speed of light. Therefore, it is highly unlikely that we will witness the star's dramatic demise during our lifetime. The unique thing about Betelgeuse is that we can actually see its surface, which isn't the case for most other stars. This gives us an incredible opportunity to learn about how big stars like Betelgeuse behave as they get older, including these kinds of surprising mass ejection events. Recently, astronomers made a spine-chilling discovery. For the first time ever, they observed a star consuming its own planet 12,000 light-years away in the constellation of Era. Betelgeuse, with its intriguing name and prominent position in the night sky, has captivated the human imagination for centuries. Its significance extends beyond scientific knowledge, as it has left its mark on pop culture and mythology around the world. Betelgeuse has a rich and diverse origin rooted in the Arabic language. Initially interpreted as the armpit of the giant, some scholars argue that it may represent a hand or shoulder instead. This anatomical association is reflected in various interpretations of Betelgeuse, often linked to anthropomorphic or animal figures across different cultures and mythologies. Betelgeuse carries multifaceted meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil it was perceived as a turtle's leg or a caiman's hind leg. The Sanskrit term for Betelgeuse translates to the moist one, tied to Hindu astrology's Ardra lunar house and associated with the tempestuous storm god Rudra. Throughout history, Betelgeuse has played a significant role in cultural practices and traditions. For instance, in Macedonian tradition, it symbolized domesticated animals and agricultural life in villages. In other regions, such as North Baffin Island and the Melville Peninsula, its rising signaled the arrival of spring and extended daylight. Betelgeuse's prominence arises from its association with the constellation Orion, where it is recognized as the star on Orion's right shoulder. Ranking as one of the sky's brightest stars, it is the 11th in luminosity and continues to captivate artists, writers, and filmmakers. Known scientifically as Betelgeuse, the star intrigues astronomers and enthusiasts with its recent transformations and potential future supernova explosion. Located prominently in Orion, Betelgeuse has been a stellar icon for millennia, its reddish hue and variability captivating diverse cultures. Recent astronomical observations have highlighted Betelgeuse's erratic behavior, revealing changes in its brightness patterns. The star's variability, initially expected to follow a regular pattern, has surprised researchers with shifts in pulsation periods and unusual dimming events. A significant observation occurred in late 2019, when Betelgeuse began a notable dimming phase that extended into early 2020. This dimming, detectable with the naked eye and advanced telescopes, was unexpected for such a prominent star and has spurred intense study to uncover the reasons behind it. Several theories have been proposed to explain Betelgeuse's dimming. One leading hypothesis suggests that the dimming might be linked to the ejection of material from the star's surface, possibly triggered by convective processes within its interior. These processes, resembling giant bubbles of hot gas rising through the star's layers, can disturb its normal pulsation and result in material being expelled into space. Although surface mass ejections, SMEs, are not uncommon, the scale and impact observed in Betelgeuse make it a unique case for study. Following Betelgeuse's dimming events, astronomers have noted changes in the star's pulsation pattern, with the usual 400-day cycle being replaced by a shorter 200-day cycle. This shift indicates significant upheaval within Betelgeuse's structure, potentially signaling ongoing instabilities that could lead to future dramatic events like a supernova. Supernova explosions represent some of the most energetic events in the universe, marking the end of massive stars' lives with a spectacular burst of light and energy. While Betelgeuse's recent behavior has led to speculation about an imminent supernova, predicting such events with certainty remains challenging. The timing of a supernova depends on internal processes within the star, including the fusion of heavier elements in its core and subsequent collapse under its own gravity. Estimated to be around 8 to 8.5 million years old, Betelgeuse is nearing the end of its life cycle. It has exhausted its hydrogen fuel and is now fusing helium in its core, a process that will continue through heavier elements until iron is produced. The formation of iron in Betelgeuse's core will signal the end of stable nuclear fusion, leading to a collapse and potential supernova explosion. If Betelgeuse were to undergo a supernova, its proximity to Earth, about 650 light-years away, would make it a stunning astronomical event visible across the galaxy. A supernova from Betelgeuse would briefly outshine its entire host galaxy, casting shadows on Earth and producing detectable signals of neutrinos and high-energy photons throughout the universe. The study of Betelgeuse's future and its potential supernova is not only a scientific pursuit but also holds cultural and historical significance. Throughout history, supernovae have been observed and recorded, often leaving lasting impacts on civilizations through their appearances in myths, legends, and historical records. For instance, the famous supernova of 1054, which resulted in the Crab Nebula, was documented by Chinese astronomers and has since been extensively studied by modern scientists. In contemporary times, advancements in observational astronomy allow for unprecedented detail and accuracy in monitoring Betelgeuse. Instruments like the Hubble Space Telescope and ground-based observatories provide continuous observations of Betelgeuse's variability, aiding astronomers in refining their models and predictions for its future evolution. Beyond its scientific value, Betelgeuse holds cultural and symbolic importance across various civilizations. Its name, derived from Arabic origins, has been interpreted differently throughout history. In Arabic astronomy, Betelgeuse was often associated with parts of the human body, reflecting ancient views on celestial objects. Across cultures, Betelgeuse's prominence in the night sky has inspired stories, artwork, and philosophical reflections on the nature of stars and their place in the universe. Looking ahead, astronomers will continue to observe Betelgeuse closely, anticipating further changes in its brightness, pulsation, and structure. The star's evolution offers a rare opportunity to witness the dynamics of massive stars nearing the end of their lives. Each observation and discovery contributes to our understanding of stellar evolution, supernova physics, and the broader implications for the fate of stars and galaxies in the cosmos. As technological advancements progress and new generations of telescopes become available, astronomers will gain even deeper insights into Betelgeuse's behavior and eventual fate. Whether it undergoes a supernova soon or continues to surprise us with its variability, Betelgeuse remains a captivating subject of study and a testament to the ever-changing and dynamic nature of the universe.